Both application engineers here at Leap Motion. A lot of what our team does is develop kind of UX demos and UX research projects, and also we develop a lot of the Unity assets and developer tools that folks use to develop motion control and virtual reality applications with the Leap Motion controller. And so we're really interested in kind of figuring out what are the sorts of design and technical things that we can do and build to create interesting interactions inside of virtual reality and inside of all of these new kind of great applications that people are building. And a lot of the work we've been doing recently has been focused on building virtual reality applications with a hybrid interface. And so we've been looking at like how do we integrate with physical controls and motion control, and how could we integrate inside of kind of existing game mechanic environments and things like that. So we've been building this Leap Motion enabled virtual reality cockpit that we actually just kind of pushed out on our dev gallery today, and we're going to be working on sharing a lot more about that project and a lot more about kind of the sorts of things we've been building, and I'll actually kind of show you where you can see that on our dev gallery while we're at it. If you go to developer.leapmotion.com and go to examples and then VR, and then I think at the moment if you scroll all the way down to the bottom, you can go find the VR cockpit, and it's a Windows only demo right now, just due to Oculus restrictions, but there's a lot of interesting stuff in there. But today we really want to focus on talking about one particular thing that we've learned a lot about, which is a lot of the challenges that revolve around interacting with buttons. It seems like a super simple thing, but there's actually kind of, Barrett talks about this matrix of complexity around like what all do you have to put into actually making a button and making it work. So we want to kind of talk a bit about the challenges we've run into, the different sorts of things that we've kind of found work well, what hasn't worked well for us, and what are kind of some of the UX best practices that we've been working with. So I guess without further ado, we'll pop into talking about. What do you think? Should we show the demo a bit and then talk about massing?
Yeah, let's show a little bit of the cockpit.
Yeah, so we can kind of show you a bit of what we're talking about here. You can see the fancy GIF up here, but let's switch over. Let me know if the audio in the cockpit is audible and if it's messing with us. So one of the things you'll be able to see here is I actually have this throttle and joystick, kind of this flight simulator setup here, and like a lot of kind of these virtual space sim games that are coming out today, this demo can utilize these, and in addition to the Leap Motion. So I'll just align my camera. Yep, I've got that. I'll do a real quick alignment here. This is very much a research project, and so we're kind of aligning our physical objects by hand right now. You can imagine how this could all be tracked in some future production demo, maybe. So here I am, I'm in my cockpit, and I've got a bunch of stuff going on, and I don't know if y'all can hear the audio, but I've got this guy kind of talk to me. I've got all of these kind of list menus here. Those will start talking if I hit them, so we'll ignore those for now.
Can't see the screen.
Can't see the screen?
Yeah.
Ah! Properties. I love having the technical support group that's watching the stream and making sure everything is working. It's actually super helpful. Or I would just kind of ramble on and have no earthly idea that anything's gone wrong.
There it is.
How's that?
That's it. Good job.
All right.
Yay.
So we're back. So, hey, as you can see, I'm in kind of my virtual reality spaceship, and this is all super pre-production, and I've got my joystick and my throttle here, and you can actually see here in the image pass-through that I've got a real-world joystick and a real-world throttle, and I can actually see those controls get him out of the way. And so we've got this kind of mock-up of a space sim cockpit, and I can fly around with the traditional controls that I would use in kind of any other space sim game. But the really interesting thing here is that I can reach out, and I've got all of these different menus and buttons and different interactions here. I can actually kind of see Barrett there, so I know I'm not going to hit him in the face. And I can interact with all these different sorts of things, and really get a very immersive set of interactions that really plays into the fantasy of I'm flying this super cool spaceship. I can really do something fancy here.
Make the jump, Daniel.
Making the jump to light speed. And so we've got kind of a lot of different interactions going on here, and there was a lot of different kind of UX challenges and things that we're exploring. But one of the core things was, how do we interact? One of the simplest building blocks is these buttons. And how are we going to work with these, and what sorts of interactions make these better? What sorts of visual and audio feedback makes these work? In our user testing, what problems do people have? Do people know they can press things and that sort of thing? But there's kind of an even simpler starting point to making all of these work and making all of these good interactions. And that's, where do you put things? And what does the actual massing kind of look like of where your interactive elements are? So to talk a bit about that, let's switch over
To pictures.
to pictures,
We will show you some pictures.
because pictures are awesome. Wow, our Twitch stuff has really given me some trouble today. Hopefully,
Stand by for pictures.
yep, incoming pictures. Yeah, come on.
So, while Daniel sets that up, what we were presented with was the problem of, we have virtual reality buttons and we have virtual reality hands, and what is the relationship of those two things? And the complexity matrix that Daniel alluded to is the idea that you have your virtual hand, you have a virtual button, but you also have a virtual camera, and you have a virtual tracking space, and you have the amount of throw that the button needs to have, and you have the angle at which the hand hits the button, and you have a variety of very simple elements but add up to a pretty complex matrix. So we really needed to try to figure out, where do we put the buttons? What's the best place for them? What's the best orientation? And we did a lot of trial and error with this, with just buttons early on, where we were building our widget framework, and we were just working on buttons and sliders and scrollers and those sorts of things. And we did a lot of user testing on just those little elements by themselves. And we learned a lot from that. And we learned a process of check and iterate here that I'll explain. As we started to build a spaceship cockpit, we needed to know, like, what kind of console should we put in front of the pilot? What's going to be easy to reach? What's going to be ergonomically comfortable? What's going to make the button pushes effective? And what would be fun? So we started doing quick massing experiments in Maya. And, in Maya, what you can do is you can quickly sketch up a model and toss it into Unity, put on the Oculus, and if you have Leap in your Unity scene, you just can start reaching out. So we would do these quick geometrical massings and do variations on this, and put somebody in the headset and say, hey, can you touch this? Hey, can you reach this? And is this comfortable? What happens when you reach over here? And what happens if you reach over here? So literally, these are 10-minute modeling tasks, 20-minute modeling tasks. Pop it into our Unity scene, and then put the helmet on, and ideally put several people in the helmet, like people with long arms and short arms, and really see what's comfortable to reach. Oftentimes we would look inside the editor window as the Unity scene was running so we could see where the virtual hands were going through these. So we tried out a bunch of variations, and this is kind of a fun iterative process. We zeroed in on what we see in our cockpit now. And Daniel, if you'd like to show us a little more of the cockpit.
Yeah, if you want to.
We came upon something inspired by helicopters and something inspired by your kind of old school DC-3 cockpit, where you can reach around and a panel will respond to you. And the panels animate into the scene, so you can see them come in, and you get kind of an indicator that some stuff is going to appear there, as opposed to just blinking on and surprising you. So we did some sculpting of these menus as well. We really wanted to give them a curvature because ergonomically your arm swings on an axis. Your arm swings in a radius. And so giving the menus a little curvature kind of hints at some of that physical reach, having a curve to it. Then we started figuring out how to trigger them, and we first experimented with just gaze control, where looking in the different directions would trigger the animated menu to come out. But then more iteration, we realized that actually reaching out with a hand in addition to looking gave the user a little bit more agency in deciding when these things would appear. So we settled in on a combination of looking and reaching to get these menus to come out. And so the menus, again, they're modeled in Maya, and they have Maya joints and animation on those joints. And then we use basic Unity Mechanim state machine for the animated behaviors, and then our logic code is controlling that with the gaze and the reach. Then Daniel's been doing a lot of work going deep in the buttons that you're seeing here, and we took and created a new evolution of the buttons that we've been working on to implement some new things we've been learning here.
Yeah, there's actually a decent number of kind of, whoop, hey, go away. There's a decent number of kind of interesting interactions and things that are happening inside of these buttons. We took a lot of time to kind of play with different audio effects, different visual effects, to try and make things a little more interactive and a little easier to use for someone, especially if you're coming in new to a motion control application. I don't know how many of you saw the virtual reality planetarium that we built, but that was kind of the first real world application, if you will, of the Unity kind of VR widget framework that we've been building. And it was successful in a lot of counts, but it actually had some problems. People didn't know what things were buttons and what things weren't. There's not really a great visual language in virtual reality for motion control yet, especially not one that people are used to. And so we wanted to think about, how do we show that things are interactive? How do we imply that you should interact with something with your hand? A lot of that comes down to making things reactive, so that when my hand comes up into the scene and I get near these things, they start to react to my hand's presence, and you can see these kind of hover effects as they light up. It starts to let me know that, hey, this thing cares about my hand. I don't know how easy it is to hear in the stream right now. Maybe if it's problematic, we can bring the audio up a little bit. But there's also, as you get nearer to these menus, there's some kind of electric buzzes and whirs that attenuate as your hand gets near them and as you move around. And all of that reactiveness is really there to let you know this is an interactive element. This is something the application cares about. And then you can see that there's a lot. So one of the big things is I don't have haptic feedback in here. I don't know when I've pressed something. I don't know when if there's resistance against me pressing something further. And so you really have to use audio and visual aids to make up for that. And so one of the things that people have a lot of trouble with is, what is the throw on this button? How far am I supposed to press? Some people come into your application and they'll press very lightly. They'll just try and tap something. Some people come in and they just push all the way through. They really want to, make sure they hit this button. And we saw that a lot with Planetarium, where we had a lot of these different kind of amounts of press. So we're experimenting with these kind of hover layer effects, where the button itself, the plane that you see back here, that plane, the moment you touch it, the button has been depressed. But you also don't want, especially when you're scrolling in here, you're doing a lot of different stuff, you don't want to just have that immediate moment be the first time that the user sees maybe the button give a little bit. So having this sort of, we've been calling them runway light hover effects, is a really useful tool.
We want to land your hand on the button.
And a lot of using this has come from watching a lot of other kind of virtual reality interactions and menus, and we've been kind of watching what other VR designers have been doing and what's worked and what hasn't. And this is something that really does a good job of helping people out in terms of VR interactions. And so as I press here, I can see this compress, and I get a really good idea of exactly how far I'm supposed to press in. And the moment I press in, I get a really nice piece of feedback that I've depressed, and then I can release, and I've got a good interaction space here. And there's also, again, you can hear as I press in. The moment I get into where I'm pressing, there's a whoom that kind of happens, and that's also about I've entered the scroll zone. Depressing, being inside this hologram zone is also the recognition that I'm inside the scroll zone of the list. And then the moment I press, I get a button press sound, which is really critical to getting people to know exactly the moment that this worked. And then also a confirm and release sound. You'll notice if I press scroll a bunch, I won't get as much of a release noise. And we'll cancel out that press. And that's actually something that's required a whole lot of tuning, is getting that getting that scroll zone to work well with the button presses. And there's still, I think we can talk a little more later about, if that's interesting to folks, kind of what went into that. It's still something we're working on and making better. But I actually want to bring up, so I talked a little bit about how there's not a good visual language for what is interactable, what's not, how do I afford this, how do I afford that, and we want to make sure that there's a consistency to the sorts of buttons and interactive elements in the application, but we don't necessarily want everything to look the same or everything to have the exact same kind of narrative or aesthetic feel to it. So we've got these kind of compressing layers as a mechanic, but there's also this whole jump button, and this has its own whole set of kind of aesthetic feel, but Barrett built this and can talk a little bit about how we kind of took that effect and brought it into something completely different.
Yeah, I'll trade headsets with you, Daniel.
Cool. Change places.
Is that trading if I don't have one? I'll trade headsets so you don't have one. All right. Okay, so learning what we've been learning from Daniel's runway lights, we started to explore other ways to treat a button. And here in a cockpit, we're going through a spaceship narrative, ostensibly. We're thinking about the kind of things people do in video games, and we want people to have an immersion in the subject of being in a spaceship cockpit. And so the buttons are physical in one way, in that they engage your body to use your hands and fingers to connect with the UI. But with this motion controller that we have, there's a slightly larger space here, and you can really use your whole arms and use more of your body. So we started thinking about the jump to hyperspace, and we said we should make it like that the pilot has to be really serious that they're going to jump to hyperspace. They got to they gotta mean it when they push this button. So it takes two hands, and if you compress one hand, this is a riff on Daniel's runway lights here, and Daniel had the good insight to make these things collapse versus just squish in like an accordion where they all maintain the same distance from each other. So that collapsing effects we connected to the sound to give you the idea of these layers touching each other. And we also wanted to make this button appear and disappear in an animated way and make its appearance and disappearance in the scene have a little bit of drama. But one of the main things that we're exploring is the idea of a larger, more immersive gesture, a more physical expression. So this idea of the two-handed push into cyberspace is
Hyperspace. We're going to hyperspace and cyberspace.
That's really way too Freudian. Thank you. This push into hyperspace is a physical gesture. So there's a lot of really fun territory to explore. I'm going to trigger this one more time. And here's the animated appearance of this thing to kind of give it a little drama as it comes into the scene. But there's a lot of really fun territory with making your body part of the UI, with making broader, bigger gestures connect to things in the virtual scene directly. And Daniel has some really good insights on this that he was sharing with me earlier. Daniel, you were talking about really connecting people to a physical manifestation of the UI as much as possible.
So one of the things in my experience so far working with virtual reality and working with motion control that I've really kind of come to believe in is that abstract gestures, there are times when they're good things to use. They're a tool, and there are times that they're good. But for a lot of interactions, abstract gesture ends up being a really difficult thing to use properly. If you ask people to pinch, if you ask people to twirl their hand in a particular way or to push their hands forward in a particular way, you'll get a lot of variation. You'll get a lot of different things. There's also recognition versus recall problems. The idea that I want someone to be in the application and recognize an opportunity to use an action or an interaction rather than have to recall that remember a particular gesture. And so gesture can be a difficult thing. And the more that you can use physical affordances and physicality inside the application to enable the different interactions, that's a much better sort of thing. So, we're thinking about hyperspace, and there's, we're gonna go to hyperspace, we're gonna move, or like, fire.
Launch the torpedo.
Exactly. There's a lot of these great kind of full arm gestures that I might want to use and that have kind of an energy to them and a physicality to them that are fantastic. But inside of an application, that's a very difficult thing to actually communicate and to teach someone how to do it in a way that you're going to detect every time and that you're going to it's really going to feel like the player's in control. And so being able to use a physical thing like this, like long throw jump button, lets us get that sort of gesture and that sort of physicality that we want, but makes it a really usable thing that people are going to consistently do the same way. And if there is a problem, it's more obvious to somebody what they're doing wrong or how that interaction isn't really working for them properly. So that I think is a big thing. If you have a gesture you want to do, figure out how you can physically afford that gesture. How can you make something in the application that I interact with that helps me do that thing? It's not to say that that abstract gesture is bad. It's just a tool for a particular job, and there's a few different tools in the toolbox there. A quick aside, I know we've had a few questions coming in, so I want to address a few things here. The first one was, can arm length be measured by the leap in VR mode? So specifically, the full length of my arm isn't something that I can measure by the leap. We do give you an elbow position and an assumed elbow position, and I believe that's scaled. I'd have to look at the API exactly, but I believe that's scaled off of our overall hand scale. What you can do though is, if I'm not mistaken, the in general, a person's arm span is proportional to their height. So if I'm 6 feet tall, my full arm span should be about 6 feet. So if you have someone who's put in their height in the Oculus user profile, and that's something your application is looking at, assuming that's something you trust that they've entered their user profile, you can do a bit to kind of extrapolate off of that. One of the things we do in this application, because arm span's a problem, especially for these side menus. You want those to be close enough that they can be interacted with, not so close that they feel confining, not so far away that the tracking isn't going to track them well when you have to reach way far out.
This distance we spend a lot of time with. We really finesse that distance.
And we've really, and it's still something I think we're kind of working on. But one of the things we're doing is you have to align your joysticks early on in the application right now, where we know where you've placed these, and if we assume that you've placed those in an ergonomically comfortable position, we actually extrapolate menu positions and things like that a lot off of that. So there's kind of some tricks we're doing there, but figuring out the ergonomics of that is definitely something that requires some effort and some thinking. This isn't something we've tried yet, but I'd be really curious to see what kind of a user alignment sort of scene ahead of your game looks like. Is it an overwhelming experience, or is it too much friction to ask people to do things like, hey, tell us your height, or to say, hey, put these things in a place where they feel like you can reach them easily. Some of that user customization might be a really interesting thing to explore. Another question was, does the experience feel awkward when interface distance is locked to your head distance? And yeah, I think it does. There's one of the things in the application here is when you first get into the application, there's a screen that says you need to press this button to align the camera, and having that in there is a really and having it locked to my head is actually a bit disconcerting in VR. You want to make really sure that it's not too close to your face, because something very close to your face that you can't get away is actually something that's going to make certain people sick. Is going to be a really disconcerting experience for people. But even something that's just locked to my vision, and especially if there's a background behind it blocking that view, doesn't feel great. The reason we're doing it there is we haven't aligned the Oculus camera yet, so we don't really know what direction you're looking. We need to make sure you see that warning, kind of like the Oculus health and safety warning. But it's I'd say it's not the best solution we could have. It's kind of a stopgap at the moment. So locking things to head distance and locking things to the head, in the way you'd kind of expect a traditional HUD to work, can be a bit disconcerting and a bit weird. So keeping things physical and keeping a little slosh, even if something maybe follows your vision, but letting you kind of slosh it around a bit, is probably a better way to go. That we haven't really gotten a chance to interact with that deeply and really explore that a huge amount. There was also a question about source code for this. The plan is to release the source for this eventually. We've still got some work to do before we're totally ready to get that out into the world. Don't want to promise a timeline right now, but it's totally our intent to get the source code for this out. The other thing we want to make sure we do in the future is take a lot of the new tools and the new things we built in this and integrate those back into our Unity core assets, so that these like hover layer effect buttons and everything, all of these are built on the existing core assets. There's nothing in here that you can't build right now with what's in our publicly released core assets, but there is a bunch of kind of new and improved things that we've been doing that we definitely want to get in there. But that's just a question of how quickly can we bring a lot of that in. So that's kind of on our radar. So yeah, that's Barrett. What's the next thing we want to look at here?
Well, we also have a little robot that guides us around the cockpit.
Mm-hmm.
We may talk about more in future sessions, but
yeah, I guess we can talk about the Ballbot a little bit.
sure. Well, again, we're in a physical narrative. We're physically in our narrative here, and we have a whole bunch of different buttons and a bunch of different widgets to play with, and also there is a hyperspace sequence that we want to have users find. We want them to be able to discover this. So we didn't want to just put a whole bunch of bullet points up in your vision here to say do this, do this, do this. So Daniel worked out a great event system for queues and a kind of a narrative flow system. And I made a ball bot that could talk to that flow system here, this spherical robot. Here, I'll get this hyperspace jump out of the way.
And that flow system is, for those of you who are in Unity, we're using, one of the things that Unity's added in the last few releases is the ability to use their Mechanum state machines, not just for animation, but as an abstract state machine. And Barrett was exploring a lot of kind of how that system worked back in the VR Planetarium. But what we did here was we used that system to build a mechanism for sequencing game events, sequencing game objectives, all of our scene transitions, and that sort of thing. So it let us very easily set up all of our kind of all of our objectives and all of our like VO queues and things like that without, and being able to very quickly iterate and change that.
So the ball bot will speak to you, and if you haven't heard the audio over our stream here, when you get to the cockpit, he'll start to tell you kind of in a narrative flavor. He'll tell you what these things are, like there's something over here you might want to look at, and there's something of interest over here, and he kind of gently guides you through things. But the other kind of Easter egg about him is that we also wanted to show that a motion-controlled device connected to VR allows you to do other things in the cockpit. We wanted to make it so that there's evidence that you can touch more of this environment than just these virtual menus. These holograms over here are cool, but what if you can affect other parts of your experience? What if you can reach out and do other things in your scene? So, you know, this robot has a collider on him, and he reacts when you hit him. So we encourage you to hit him when you fly the cockpit, when you try out the demo. He will be able to, he'll be fine.
As I think one of our audio assets says, he is in fact invincible.
Ethically, it's not a problem, we promise. But you know, there's another type of action that you can do with your hands, one that's bound to the narrative, one that's more connected to the environment. And we wanted to just make him do double duty of not only guiding you through the cockpit experience, but also kind of giving you a flavor of what it's like to be able to reach out and touch your virtual environment.
For what it's worth, there's a couple other questions coming in here. There was a comment, it would be really cool if the little the sliders up top had the same kind of rings or kind of visual affordances to let you know how far before it was pushed or pulled. And actually, yeah, we have a branch where we're working on that. There's a bunch of stuff in there that we're kind of playing with and trying to see, you know, make that experience feel just right. But that's definitely something we're playing with.
Pardon me a moment.
And then there was also a question, hey, the X52 joysticks that you all are using have some LEDs on them. Could you calibrate and track their positions off of that? Could be the same as active or reflective markers. And yeah, there's a lot of possible ways that we could track the joysticks. For right now, it's one of those things where our tracking team, you know, they want to stay focused right now on making sure that the hand tracking that we offer is as good as it possibly can be, and they're on a pretty tight release schedule where they're trying to push updates all the time. So we didn't want to pull them off that just for a research project for right now. But yeah, absolutely. There's a ton of ways that you know, joystick tracking or something like that could work. You know, you could use, there's markered solutions. There's tracking the LEDs. That's not something I've looked at yet, but that's totally something that if this became a product eventually, if something like this were to happen, that's technically very possible. as I saw a comment that it would be cool to integrate a steering wheel like these joysticks. Barrett and I have both been playing a whole lot of Project Cars recently, so I think just being able to wave at the crowd when you win would be a pretty fun interaction. But yeah, the what else is worth looking at here? And
We haven't looked at the back of the ship.
oh yeah. No, we were really thinking about putting like the back seat of a Honda Odyssey in here and like a kid with an iPad or something, but we figured that that might be a little bit out of scope. What sort of does anyone who's watching any additional questions, anything we can kind of talk about that we're working on or anything like that from the cockpit or from kind of these button interactions? It might be worth actually, if you want to bring up one of these menus, there's kind of a question about what sort of what happens when a press doesn't work right. You have to close the pop-up. It locks the menu out.
Yeah.
I finally fixed that bug. So there's kind of a question of what happens when you interact with say the buttons in the list, but maybe you press two buttons, or maybe it's unclear what you were trying to press, or maybe you were or maybe you've scrolled just a little too much, and so we're not sure, are you trying to scroll or are you trying to press a button? What do you do in those situations? And that's something that we've actually been experimenting with a lot of different ideas, but we haven't quite been able to come up with something that we're particularly happy with. We've looked at, when you press, what if I press two buttons simultaneously and I release nearly simultaneously? Right now, if I'm not mistaken, we grab the first, on the left-hand menu, we grab the first release. On the right-hand menu, we grab the last release, trying a few different kind of things. We've also tried where if it's ambiguous, we turn both those buttons red and don't take either press. And that kind of, that fail closed mentality didn't perform particularly well in our user testing. But that's something that we're looking at more right now. At the moment, there's a when you enter the scroll zone and when you start to press, there's kind of a certain amount of give where if you move up or down or scroll just a little bit and you press and release, you'll still get a button press. But if you've scrolled over a certain amount, we lock out the button press, even if you've pressed down and haven't released yet. And that seems to work pretty well, though there's kind of a lot of tuning that has to go into that. But that's a really interesting kind of set of problems and set of things that requires a whole lot of tuning and a whole lot of thought to really make it work well.
And really just putting a lot of people in the seat, putting a lot of people in the headset and watching carefully. A lot of people in our office, people from outside the office, and just this is one of the themes of our work here on both Cockpit and Planetarium and the widgets that we've been doing, is that we have to have so many users test this stuff to see how it performs. And we really do put tens of people through each of these things over and over again to watch the success rates and watch how they try to press things, watch their success or failure. And it takes a lot of rinsing and repeating to get here, and we have a lot more learning to do.
Yeah, absolutely. There's a question here about is there direct image access available through the API? And yes, there is. And I am momentarily trying to find. I haven't actually. We kind of set that one up, and it's kind of built into our assets, to the Unity assets. So I actually haven't had to look at that API in a long time, though we've been doing a ton of work with the images. There is I believe the image is a property, I believe you pull the image directly off the controller in the same way you pull the latest frame off the controller. But if you go onto our API reference on developer.leapmotion, you can pull that one up pretty directly. Let me see if I can speak to it. Yeah, if you look at the controller, there's an image. If you look at the controller object in the API, there's an image list object that you can pull off of that controller.images, which will give you a list of the images coming off of the frames. The image data and the frame data, they can technically be running at different rates, and so there's a little bit that you have to look into there, but it's relatively straightforward. There was another question in here. Have we tried calibrating arm length by having the user reach out and having the UI elements be a certain percentage away from that to compensate for different arm lengths? Calibration is something that we've talked a lot about, and we haven't really had an opportunity yet to really dig deep into that. I'd be really interested to see what a lightweight sort of UI calibration or arm length calibration routine would look like. Maybe something that could be fit into the narrative and could stay fun and could stay interesting. I don't know, Barrett, do you have any thoughts on the calibration side?
It's definitely something that we've been talking about, and it really does vary from user to user, and we've talked about bringing these things farther in or farther out based on arm length, but getting that arm length is something that you have to measure. I don't know if that's helpful or not.
Yeah, and that's kind of the question, is like, what does a calibration routine to measure that arm length look like, and what could that look like, and have we messed with that? But
Yeah, I mean, we can guide the user to reach to a certain place, but that actually puts them in a specific place. We need to have them reach and extend,
yep.
and get that point in 3D space. But once their hand is there, we can see where it is,
Yeah.
and yeah, we can use that information. It's something that's been on our minds.
And a lot of the reason we haven't looked at that as much is primarily that we're trying to see, like, we're trying to figure out, hey, can we do this in a really lightweight way that doesn't require a whole lot of calibration? I know, like, one of the big pain points with a lot of motion control software and a lot of motion control things is the need for an excessive amount of calibration. You know, when I first get my Kinect or something, I might spend an hour or two getting my room set up, getting everything angled just right. And I mean, you know, that's kind of part of the technology, and they did a great job on that team of making that a fun experience and kind of adding some gaming elements to that and making that really great. But we've kind of been pushing ourselves to figure out how lightweight can we go before that trade-off isn't worth it. But calibration like that is something I'm super interested in.
And one of the things we did here for the jump button is right as soon as we turned this on in the cockpit, we had a bunch of people of different heights. I specifically went around our office and looked for people with the shortest arms and people with the longest arms and put them here, and made sure that the people with the longest arms weren't going through this, made sure people with the shortest arms could reach this length. So, you know, in this case, we're just finding a sweet spot that works for most people, and but doing some deliberate measuring is definitely territory to explore.
I think the other thing to point out with this is that we actually wrote an interesting little routine for recentering the camera. So when we're trying to align with real world objects like these two joysticks, the joystick and throttle here, and so we want to make sure that our assumed alignment stays proper even when we switch people in and out of the application, and we need to maybe realign. So like if you look straight ahead and do that realignment with the joystick there, which is the T2 button on the stick.
Oh yes, thank you.
We've been changing those controls around a lot.
You can see the image jump a
And
little
yeah,
bit
and
when I
if
do
Barrett
that.
moves his head around a little bit and then redoes it, you can see the image jump. But we actually wrote an alignment routine that tracks the realignment, moves the joysticks so that they stay in physical alignment. We're also only rotating we're only moving the cockpit in depth and verticality. We're not moving side to side, and we're not rotating it so that you stay in physical alignment. But we can still reorient the cockpit when a new player comes in, make sure that everything lines up well. We've been showing this a lot at conferences and meetups and things like that, and so rolling a lot of different people through it and being able to quickly recalibrate and recenter so things are kind of in the right place for them has been really important. First few times we did this without having that was difficult, so we had to go do that. There's a question, is there a way to fake skeletal tracking of the hand during occlusion? Find that a lot of experiences drop the tracking for a moment and when a few fingers are behind the hand. In terms of faking the skeletal tracking, the system we have, the actual leap motion tracking really does a lot of work to figure out, you know, I can't see this current data. I'm going to make some assumptions about where, like, I can't see this finger, I'm going to make some assumptions about where it probably is. A lot of our algorithms deal with that sort of kind of fuzzy tracking and figuring out what's going on. That said, all of our, in Unity at least, all of our hand models, if you've got a routine or something that works well for your game, contextually you have a really good idea of what the hand is probably doing right now, all of our hand models, you could override and reposition those hand models yourself. So one of the things that Barrett and I have been playing a lot with is taking the skeletal track and actually overriding it in late update, or blending it with a set Mechanum animation to kind of allow us to move in between track data and application controlled hand data. That becomes a little more difficult with the image hands, because you need the actual, to make that effect work, you need the video image coming from the Leap Motion, and that's a difficult thing to synthesize on the fly. But
yeah, we did some decent experimentations with the 3D hands of blending between an animated position and the tracking, and being able to seamlessly go from animation, where your game is controlling, to the tracking control.
yeah, but the but in terms of like, could you do that? Could you kind of have maybe an idle position that you bring the hand to, or something like that? It's absolutely doable. If you look at the hand model, the quickest way to do it is look at the hand model object and start overriding it in Unity's late update. You get into some weird kind of race condition situations where if like multiple things are trying to override in late update, there's no guarantees on who runs first. But we're, I believe, not running those in late update. I believe the physics hand does get run in late update so that it pairs well with the physics system, but it's quite doable. We've experimented with that ourselves, so it can be built. The experiments we've had aren't super polished right now, so it's not something where we've got like source that's in good shape, but it's definitely something that's worth exploring. And if you do explore that, we'd love to kind of hear what your results look like and what's going on, because that's something we're pretty interested in. The idea that like within our tracking algorithms, we know what's happening in the world. We see the images that the Leap sees, and we can make assumptions about that. But as an application developer, you know far more information than our tracking algorithms do, because you know the context within your application. You know that this hand is near this menu. You know that I'm on my start screen. I'm not going to be doing a particular gesture very often. Things like that. You know my hand is near this joystick, and I'm probably going to grab. So there's a lot you can do once you know about your application context to take the data that's coming from tracking and pair that with that information to make intelligent decisions about what your application does and how you respond to user input. And I think that's kind of a large, very underutilized design space that can really improve the quality of applications.
Daniel?
Yep.
Stand back a second. Just prepare yourself.
There is a microphone in front of you.
Whoa.
The first time we got the sounds in, especially for hitting the ball bot and knocking him around the cabin, I'm like, during our code review, I instead spent about 45 minutes just batting him around the cabin, listening to it. It's surprisingly fun.
We haven't made anybody slap anybody else yet, but it could happen.
I knocked an empty soda can off my desk at one point, just because I wasn't paying attention.
I've accidentally hit my monitor on more than one occasion. That's part of that calibration thing we were talking about.
Yeah, exactly. Some more questions coming in. Is there an easy way to detect the hands in Unity without going into code? That is a good question. So you can just drop the hand controller prefab directly into your scene, or there's like a number of different kind of like there's like an OVR there's an OVR Leap camera rig prefab from our core assets that you can drop in, and that will get the hands into your scene pretty much immediately. This would actually be
And after that, once you have the Leap hands in your scene, then dropping in physics objects with colliders on them allows you to just bat things around in your scene, and there's an enormous variety of things you can do with little or no coding at that point. Anything that is physically collidable can interact with the Leap hands. So you can scaffold yourself up gently to more complex interactions.
And you know what? The thing that immediately occurs to me is that one of the applications that was one of the finalists and one of the winners of our 3D jam that we did with IndieCade was weightless. And
He's in the chat.
is Martin in the chat? Oh, okay, good.
Hi, Martin.
Hi, Martin. Martin should absolutely do one of these Twitch streams on building Weightless, because Weightless was actually built with a very small amount of code and was built, I believe, with a whole lot of, I think it was Playmaker.
Correct.
And so I've only seen a little of what he did, and it's really impressive. And we should absolutely have him talk about what sort of stuff he did, how he built an application with Leap Motion with a very small amount of actual code.
And you know, it's worth mentioning the Mecanum state machine here in Unity 5 is pretty powerful.
Yep.
And what I would suggest, from what Daniel and I have been learning from deep dives into the Mecanum state machine, is there's a threshold you'll reach in trying to make complex gameplay and that sort of thing, where the visual state machine becomes a little bit unwieldy. But there is infinite variety of simple interactions that you can do without coding, with using the Leap Mecanum state machine as an abstract state machine, where it doesn't trigger any animation, it doesn't do anything but trigger events in your scene. So there's an enormous array of interactions you can make. Many types of applications can be made with that. I think with the caveat that it can get a little bit unwieldy if you try to make a deeper game all in the visual interface.
Right, and that's where something like Playmaker, and I'll let Martin speak more to that, but that's where something like Playmaker is kind of built for taking that next deeper dive down.
Yeah. Yep.
So that stuff is, and that's actually not something I have a lot of experience in, but it's pretty cool.
We did a fair amount of the BallBot's hosting behavior here, where he guides you around the scene as Mecanum flowcharts, where we visually choreograph him through the scene using Daniel's event system.
And that may be something we do a blog post on or something like that in the future. It's not a particularly, it's not like some super novel system, but I think it's something that was super helpful to us. So it would be cool to kind of share some of that.
Yeah.
There was a question here. Is there going to be a document illustrating which affordances are recommended and which aren't?
We have a best practices document.
Yeah. So there's a few things that already kind of exist. There's a lot of stuff kind of all over the place. There's a Leap Motion best practices document, which hopefully somebody in the chat can find a link to that and throw that up. That exists, and that has a lot of really good best practices. There's a number of blog posts that we've done in the past. I think there was a kind of the Build a Button workshop blog post, and there's a lot of stuff we talked about when we built the VR Planetarium about kind of what the best practices were there, and we're absolutely going to be documenting and talking a lot more about the specific kind of affordances and the do's and don'ts that we learned from this application. The real struggle, I think, with having, like, you know, everyone calls out like the Apple human interface specification for the iPhone and for touch whenever they talk about documents like this. And I think the rest of the community are learning so quickly, and we're trying so many different things as a design and development community that it's really difficult to pin down, because the best practices today, there's going to be new and better and more awesome ideas tomorrow and next week. Every day I come in, we're not the only folks doing kind of front-end UX design work at Leap. There's a bunch of other teams that are doing really awesome stuff, and every day we come in and we see something new, and it's just like, oh man, no, how are we going to top that? You know, there's always kind of the next thing. So we do our best to kind of keep new documents flowing and new things flowing. So we'll be documenting the best practices from this and putting those out. And
another answer to your question is that the widgets that we've been building, and some of you are probably familiar with these, but if some of you are new to the Leap and haven't discovered the widgets yet, these are the affordances that we have built, we have user tested, we have iterated pretty extensively on the code inside these widgets. And there's quite a few developer hours in those widgets that represent a lot of trial and error.
Yeah.
We've tried a lot of solutions. We've had buttons that are based solely on Unity physics, and we were forced to write our own spring systems and write our own simplified physics that do exactly what we need those buttons to do.
The PhysX springs, no.
They were great.
They're not really happy things when you're trying to do a lot.
to have the kind of precision that we need for these button pushes and that sort of thing, we need to roll our own. So these affordances that we have so far are really just scratching the surface, but they do embody quite a lot of iteration on our part.
Yeah, I absolutely don't want to give the impression that we have all the answers or that
Yeah.
we think we've solved any of this. We're learning every day, and I really feel like the whole community is learning every day. And we're looking at what other designers and developers are doing and trying to build on that. And we're trying to share what we're doing so that other people can be building on that too. So
I'm going to go ahead and say that that's like half of the fun of doing what we do is we get to like try out new things, and we're getting to watch other people do it simultaneously. So much discovery going on in UX here. It's really a Wild West frontier.
Yeah, it's really fantastic, especially when we've had a few things where we've seen people take some of the stuff we've built and build on it and build something better than we had ever actually thought of or like had even like considered, and that's been really awesome. It's like, wow, they seriously one-upped us.
Yes. Yes.
And that's really great. It's because we get to learn from that and build the next thing.
Yes.
There's a question here: can you reach out and reach all the commands with a DK1? Yes, you can, because I've accidentally not put plugged my positional tracker in. Yes, you can, but with the caveat that we make a lot of assumptions about having the positional tracker. All of the real-world object alignment for the sticks assumes and necessitates a positional tracker, and the ergonomics really do assume that you can lean your body a bit and that you can move around. So I believe
We don't have one handy to test, but it should work.
And plug our. I haven't tried every single interaction, and we're not QAing with a DK1 or anything. But it's just a little. It's a little too much for us to try and support. And I hate to call something that like came out less than a year ago, maybe legacy hardware. But at this point, legacy hardware.
Much churn.
We're moving fast.
Much churn.
The world is moving fast. But you should be able to have some level of experience with the DK1. I'd actually be really interested in whether you can read the text in the DK1. I think that might actually be an issue there too. But it is, so we're coming up on kind of 6:10, and I know we're gonna have to jump into we're actually kind of brainstorming about our next set of tasks and what this team's working on for the next few months. I think figuring out what our integration, getting source code out to people, and some of the next research topics. So I think we actually have to jump into a meeting.
Thanks, y'all. Thanks for talking with us.
Yeah, thanks so much. This should be archived online if anyone wants to jump back into it. We're gonna be presenting a bunch more on the cockpit. We learned a whole lot on this, and we really want to share some of that with y'all. So we're going to be kind of in the next few months working on a bunch of that and trying to get as much as we can out. And
thanks for all the awesome questions.
Yeah, was it community.leapmotion.com for the forums if you've got questions? Developer.leapmotion.com for all of our resources and all of our demos and applications and our source code.
Tune in next month, or tune in 2 weeks for the next Twitch.
See you, everybody.
2 weeks for the next Twitch. For those who can't hear Anthony on the microphone.
There's Anthony.
Yep.
Hey, what's up?
A little behind the scenes.
Bye, everybody.
Thanks so much, y'all, and I will